Welcome to
Nay.
Do it.
Channel Everyone. Okay, deep breath. Hi team, so today's paper, it has a very polite title. It's basically asking, when should an AI agent ask for help?
When to ask uncertainty-gated language assistance for reinforcement learning. It's less about politeness and more about efficiency and cost.
Exactly. Let's set the stage. Imagine you've trained a super smart video game AI. It knows one level perfectly. But then, you drop it into a new, weird version of the level. Everything is slightly off. What happens?
It panics, goes completely random, like me trying to assemble IKEA furniture without the instructions.
That's actually a good analogy. The agent encounters an out-of-distribution scenario, its internal model is wrong, so its actions become high uncertainty, chaotic.
Right now, we have these giant language models, like GPT-4. They're like encyclopedias of common sense. You could ask it for advice on the new IKEA piece.
So why not just have the AI agent ask the language model for help all the time? Problem solved.
Two big reasons, cost and competence. Querying a massive model for every single decision is computationally expensive, slow, and these models aren't actually great at long-term planning on their own. They might give a good next step, but a terrible strategy.
So this paper proposes a hybrid, a smart gatekeeper. You keep your original, efficient, trained AI policy. It runs most of the time, but you also give it a way to measure its own confusion.
How does it know it's confused?
They use a technique called Monte Carlo dropout. Think of it like asking your trained AI the same question, but slightly messing with its brain each time. If it's in a familiar situation, it gives the same confident answer every time. Low uncertainty, if it's confused. The answers are all over the place. High uncertainty.
And that's the trigger. They set a threshold. Only when the agent's uncertainty is high does it stop and ask the language model for a suggested action. The smaller, cheaper language model.
Ah, so it's not using the giant expensive model for everything. It's using its own skills until it hits something weird. Then it goes, I'm lost. Hey, language model, what seems reasonable here?
Precisely. They call this system ASK, adaptive safety through knowledge. The key is the adaptive part. It doesn't ask all the time, it asks when it needs to.
Their test was on a grid world called Frozen Lake. The trained agent knew one layout, then they transferred it to new jumbled layouts. The vanilla agent failed. The agent that always asked the language model did okay, but was inefficient, the ask agent. It used its own policy on familiar patches, and only asked for help at the confusing new obstacles.
And the results.
In the original training environment, ASK showed no improvement, which makes sense. The original policy was already perfect there, no need to ask, but in the new jumbled transfer tasks, ASK achieved a near-perfect score, 0.95. It navigated robustly by knowing when it didn't know.
The big takeaway isn't just that combining neural and symbolic systems works. It's that the how is critical. Simple combination is messy. You need careful orchestration, a gatekeeper, the right model for the right job at the right time.
So it's like, you don't call a world-renowned chef to make you instant noodles. You use your own skills for that. But if you're trying to cook a complex new dish, that's when you call for expert advice.
That's a wonderful way to put it, Isabel. The agent is learning its own culinary limits.
And hopefully, that leads to more robust, efficient, and ultimately safer AI systems, ones that know their boundaries.
Fascinating. Thank you both, JJ, Jiyoung, for climbing that ladder with me, and thank you for watching. We'll see you next time.
Thank you.
Thanks.